Okay, there's two parts to this lesson. The first is on graphing nonlinear inequalities on two variables, which means on a Cartesian plane, just like we were doing with the linear equations or inequalities, sorry, last video. So, and then the second part, we're going to just take a look at what it looks like on a number line when you only have one variable. So to graph a nonlinear inequality of two variables, we use a really similar approach to what we did with the linear system. So first of all, you graph that equation, y equals whatever, as an equals instead of less than or greater than, or less than or equal to, greater than or equal to. And then step two is you decide if it's going to be a solid line or a dotted line, and of course it's a solid line if it's less than or equal to, greater than or equal to, or a dotted line if it's not equal to that line. And then, just like we did with the linear inequalities, we test a point, and if that point is in the solution area, then we shade in that area. If it's not, we shade in the other side of the curve. Okay, so let's take a look at this through an example. If we have y is less than or equal to x squared minus 4x, well, think about this as y equals x squared minus 4x. And to graph that, there's a few different approaches. I'm going to complete the square so that I can see what the entire thing looks like. So I need to take half of this b value, which is negative 2, square it, which is 4. I have to add 4 and subtract 4. That completes the square, so this becomes x minus 2 squared minus 4. And now I can graph this by remembering that this is a parabola with a vertex at 2, negative 4, and then it's a regular a is 1, so it goes up 1, 1, 2, 4, 3, 9, and this is a solid line. So draw a nice curve that looks like a solid line. And I've picked one now where testing 0, 0 isn't a good option because 0, 0 is right on the border. So pick a different value to go and test, maybe at this point, right in the middle. It doesn't matter as long as it's not close to one of the edges, so you're not quite sure, is it on this side or on this side. So this is the point 2, 0 that I'm going to go test. And you test it into the original equation, so the original or inequality, which was this, so y is 0 and x is 2, so 0 less than 4 minus 8 is 0 less than or equal to negative 4. No, it is not. 0 is bigger than negative 4, so it's not the area inside the parabola. The solution is this giant area outside of the parabola. And that's all you have to do. Okay, let's take a look and see what happens if we just work with one variable. So as I said earlier, we can also solve nonlinear inequalities of one variable. For example, you could just have x squared minus x minus 12 is less than 0. So you notice there's no y values here, it's just x values, and so I can't graph this on a Cartesian plane, but I can show my answer on a number line, just a straight line. So we do a very similar approach to what we had done before. Let me list those steps out and then work through them here. So the first step is solve this equation as the inequality, as though it were an equality. And so I'm solving x squared minus x minus 12 equals 0. And of course, to do that, I have to solve, usually by factoring. But I guess I could use quadratic equation or completing the square as well. So luckily this one factors x minus 4 and x plus 3. And so I get x is 4 and x is negative 3. And so I go on to my next step, which is to put these solutions on a number line. So a number line goes usually with 0 in the middle. Now you don't really have to worry about scale, like counting 1, 2, 3, 4, 5, 6, 7, 8. But 4 is over here somewhere and negative 3 is over here somewhere. So I put those numbers like that on the number line. If I'm working with an equation, an inequality where it is less than or greater than, then I use an open circle at my solution points. If I'm dealing with less than or equal to or greater than or equal to, then I make sure that I fill in my circle. So in this case I just had a less than, a greater than, so I have open circles like this. And then the last step is, basically the last step for showing this graphically, is to test the zones. So what I mean by that is there's a zone less than 3, there's a zone between negative 3 and 4, and there's a zone bigger than 4. So I pick a number in each of those zones and substitute it back into the original inequality and see what happens. So for instance, I could try negative 10. Somewhere over here is negative 10. So negative 10 squared minus negative 10 minus 12, is that greater than or equal to 0? Well, is 100 plus 10 take away 12 greater than 0? It sure is. So this direction here is part of my solution. So I draw an arrow either like that or across the top like this to indicate the solution. Now I need to test a number between negative 3 and 4, and 0 is sitting there to be tested. So 0 squared minus 0 minus 12, is that greater than 0? Well, is minus 12 greater than 0? No, it's not, so this zone is not part of my answer, and I don't shade it in. And now I pick a number bigger than 4, so I'll just do positive 10. So 10 squared minus 10 minus 12, is that bigger than 0? Is 100 take away 10 take away 12 bigger than 0? And it is. So on this side here again, I shade it in. And so there's a graphical representation of my solution to the inequality x squared minus x minus 12 is greater than 0. I can also state an algebraic solution, or sometimes this is called an interval solution. And so I know that my solution, the green part, is x values that are less than negative 3 on this part, or x values that are greater than 4. So there's a nice easy way to show the solution as well. If you've ever learned about interval notation, then the solution is from negative infinity all the way up to negative 3, or from 4 all the way up to infinity. The interval solutions are a little trickier, and if you don't remember them, then make sure you ask about those in class. And that is all there is for one variables.